This is Dr. Holt, and in this video I have three forces being applied to a 5 kilogram object, and we're going to determine what the acceleration is going to be of the object. Here I have no friction, it's on a frictionless surface. To work these problems, always note that the summation of forces in a direction, we'll make this into the x direction, is always equal to the mass of the object times its acceleration in that same direction. So I'm going to break this 8 newtons into components, and to do that I'll just draw it separately here. So we know its components again are going to go down and across, because we always add vectors, tail tail, head tail, and then we end up head head. This angle right here is going to be your 30 degrees. The 8 newtons is the hypotenuse, so this component would be 8 times the cosine of 30 degrees. This component here would be 8 times the sine of 30 degrees. I will run those numbers. 8 times the cosine of 30 gives me 6.928. And again, that's a vector going that way. 8 times the sine of 30 degrees. That's going to give me 4 newton. And again, it's a vector going down like this. Alright, so now we're ready to sum everything, and we're going to sum the forces in the x, set equal to mass times acceleration, and we're also going to sum the forces in the y and set it equal to mass times acceleration in the y direction. However, since this is on a surface, we know the acceleration of y vector is going to be 0, because this object's not going to accelerate through the surface here. So we'll do the y's first. In this case, if I did that, I would get minus 8 here. And before I do that, let's draw the free body diagram, or force diagram. To draw the force body diagram, I show a point. I'll have 5 times 9.8 coming down. So 5 times 9.8 coming down gives me a value of 49 newtons here. Now I do this component, which we calculate right here, but it's 4 newtons. I would show it back going down, back down 4 newtons. And then the normal force pushing back up, which would be the surface pushing back up on this block, would be the sum of those, which would give me 53 newtons. Let me rewrite that. 53 newtons. Hope if I could add, huh? 53 newtons. Alright, so as you know here, the acceleration is 0 because everything, the net force here is 0. Alright, now we're ready to do the x component. We summation the forces in the x direction. We come to the first one here. We had 6.928. So we'll say 6.93 newtons, round there. That's going to be positive. I have 12 newtons coming here. I have minus 10. It's going back the other way. We add those together. That'll give us 8.93 newtons going this direction here. We go back to this equation and we set it equal to mass times acceleration, and the mass will be 5 and it'll be the acceleration of x. So to solve, we take 8.93, we divide it by 5, and again this has to be in kilograms and this unit here has to be in newtons, and when we do that we will get 8.93 divided by 5 gives me acceleration going to the right of a value of 1.7, we'll round a little bit, 9 meters per second squared. Again, that's a vector quantity and it's going this direction. And that would be it. That's how you find the value of the acceleration. And it would be going in this direction here to the right, and that's how you find acceleration. again, it all goes back to the summation of forces equals mass times acceleration. I set this up in one direction, and I set up another direction. In one direction, I have an acceleration of 0 because, excuse me, this surface is supporting the mass, which is preventing the mass from accelerating downward. So in this case, my normal force will be the sum of these two. When I did it here, when I tried to find out my net force in this case is going to be 8.93 newtons, and that's going to allow me to find the acceleration going to the right. Alright, hope this video helps you guys.